Good morning, my dear students. Today we will discuss chemistry topic module 3, that is organic reaction mechanism. I am Dr. Suvadra from University of Engineering and Management. So I put some prerequisite MCQ question for to solve. I hope you can all solve this question very easily. So to enter into the reaction mechanism of organic reaction, there you have to know what are the types of reaction. First is addition reaction. What is addition reaction? Here is an example of addition reaction. If an alkene reacts with hydrobromic acid, it will give the haloethane or bromoethane. So ethylene here reacts with HBr and gives bromoethane. So component A adds with component B and it is giving a addition product. Now next is elimination reaction. If you take ethanol and if ethanol undergoes acid catalysis reaction, then it will form an alkene. That is, from single bond you are converting in a double bonded compound, and in the course of reaction you are eliminating some part of it. That is, water molecule here eliminated. So it is called elimination reaction. Now next comes substitution reaction. The basic structure of the component remains the same in the reactant and the product, but some of the molecules, some of the atom is getting replaced by other. Now if methane reacts with chlorine in presence of light, it is giving chloromethane. So here hydrogen is replaced by chlorine. So it is a kind of substitution reaction. Now there is another kind of reaction, it is called the rearrangement reaction. Rearrangement reaction, the molecule undergoes a change in which the atoms are rearranged. So if you want to convert one butene through acid catalysis to 2-butene, it is called the rearrangement reaction. Now how organic reaction occurs? Organic reaction may take place in a single step or in number of steps. If it is a one-step reaction, that is, how many bonds are broken or formed is immaterial, but the whole reaction takes place in one step only. It is called the concerted reaction. Second is stepwise reaction. If a reactant is converted to product through a number of steps and it is going through reaction intermediate, it is called the stepwise reaction. Now, there are two processes by which the bonds can be broken. One is called homolysis or homolytic cleavage. Another is called heterolysis or heterolytic cleavage. Now, say here one molecule is there, AB. A and B is forming a bond. Now, if bond is broken in such a way that both A and B are getting the equal share of electron, then it is called the homolysis. Homo means equal, lysis means breaking. So it is getting equal share of electron. Both A and B are getting the equal share of electron. Now heterolysis. Heterolysis means, hetero means unequal. So heterolysis means unequal division of electrons. If AB divides, maybe it may happen that A is converted to positively charged ion, B is converted to negatively charged ion. It may happen A is converted to negatively charged ion, B is converted to positively charged ion. But in both the cases, there is an unequal share of electron. One is getting more electron, one is getting less electron. That's how positive and negative centers are generated. So it is called the heterolysis cleavage. Now there is some way how you will represent homolysis and heterolysis. Homolysis, again I am telling, homo means equal, lysis means breaking. So it is when AB molecule undergoes homolysis, A and B are getting equal share of electron, and homolysis must be represented by half-headed arrow. So after homolysis you are getting A dot, B dot. What is it is called? It is called radical. In the next slide, we will discuss it elaborately. So to represent homolysis, you must use fish hook arrow or half-headed arrow. In case of heterolysis, where unequal sharing, unequal division of electron takes place, A is getting less electron, B is getting more electron, thus B is converting to negatively charged ion and A is converted to the positively charged ion. So here unequal sharing of electron takes place. This heterolysis represented by full-headed arrow. So full-headed curved arrow is required to show the migration of electron pair. Now, homolysis generates two uncharged species with unpaired electron. So, it is the equal share of electron both the species are getting, and the reactive intermediate with single unpaired electron is called the radical. So, what is the result of homolysis cleavage? Result of homolysis cleavage is the generation of radical, right? Now, radicals are very much unstable because they contain an atom that does not fulfill its octet. Now, in case of heterolysis, what is happening? One is getting more number of electron, one is getting less number of electron. So, there may be generation of carbocation or carboanion. Carbocation means carbon containing positive charge. So, it is called carbocation, and again it does not fulfill the octet. So, it is seeking electron. And carboanion means it is having one lone pair of electron. Carbon containing negatively charged is called carboanion. Now, radicals and carbocations are electrophiles. Now, you are getting a new term called electrophiles. What is electrophiles? Electrophiles is an electron-loving species. Electrophiles, philes means loving, electron means electron. So, electron-loving species is called the electrophiles. Now, radical and carbocation, as because both are lacking octet fulfillment, so they seek more electrons. So, they are electrophiles or electron-loving species. On the contrary, carbanion have an octet with a lone pair of electrons. So, it is very much rich in electron, and it is called nucleophile or nucleus-loving element. Now, till now we have discussed how bond is breaking. Now I will tell you how bond formation takes place. Again, bond formation takes place in two different ways. One is, if you have radical, A radical and B radical both have equal amount of electron, so A will donate one electron, B will donate one electron. The electron pair will be shared by both the atom and they will form a bond. So, one electron may come from each atom. On the contrary, if you have ions, that is positively charged ion and negatively charged ion, what will happen? A is lacking electron, but B is rich in electron. So, both the electron will come from B and it will share the electron pair. AB will share the electron pair. So, bond formation also may occur in two ways. By equal donation of electron or by unequal donation of electron. And bond formation always release energy, because after bond formation it will get some kind of stabilization. Now, these are some types of arrows that we will use randomly when we will discuss about different organic reaction. This is a reaction arrow. This is drawn between the starting material and the product in the equation. Double reaction arrow, when we will use this? If we want to denote the equilibrium reaction, that is starting material and the product are in equilibrium with each other, then we will use this kind of arrow, that is double reaction arrow. Double-headed arrow. Double-headed arrow we will use for resonance structure. Full-headed curved arrow I have already discussed. We will use this full-headed curved arrow for showing the movement of electron pair, and half-headed curved arrow for showing the single electron. Now, nucleophile, again I am discussing this. I have already told you that nucleophile is nucleus-loving species and they attack the region of low electron density, and nucleophiles are generally electron rich. They may be negatively ions including carbanion or maybe neutral molecules with free electron pair. These are some examples of nucleophile. like chloride ion, bromide ion, these all are nucleophile. What is electrophile? Electrophile is a agent which is electron loving and indicates that it attacks the region of high electron density in the substrate molecule. Electrophiles are obviously electron deficient. There may be carbonium ion or neutral molecules with electron deficient center, like H plus ion, NO2 plus ion. These all are the example of electrophiles. Now I will discuss some kind of effects. There are different effects that will require to discuss the organic reactions. First one is inductive effect. What is inductive effect? The inductive effect is related to the ability of substituent to either withdraw or donate electron density to the attached carbon atom based on the ability of the substituent, that, and it can be classified by electron withdrawing effect, that is called the minus I effect, or negative inductive effect, or electron donating group relative to hydrogen. It is called the plus I effect or positive inductive effect. I'll discuss these things using this compound. It is chloroethane. In chloroethane, chlorine is more electron loving. That is, it will pull the bond pair of electron towards itself, as it is more electronegative than carbon. So, because chlorine is more electronegative than carbon, it will pull the electron pair towards itself. So, it will generate del negative center and carbon will become del positive. As long as carbon become del positive, though it have no difference in electronegativity between these two carbon, there is no electronegativity difference, but because it is generating some del positive charge, again it will pull some bond pair of electron towards itself. So again, small amount of del positive charge will generate on this carbon. So this kind of polarization of the sigma bond is called the inductive effect. These are the groups which shows the plus I effect. These are the groups which shows the minus I effect. Next is resonance effect. What is resonance? When a compound can be represented by more than one Lewis structure and the actual structure is hybrid of all the structure, the compound is said to possess resonance. So resonance structure can also be denoted as canonical structure. You have to remember this is a hypothetical structure and do not represent any real molecule. Resonance structure, you have to remember two things. The position of the nuclei must be same in all the structure, and the same number of unpaired electrons should be present in all the structure. And what is resonance energy? The energy of the actual structure of the molecule, that is the resonance hybrid, is lower than that of any of the resonance structure. The difference in energy between the actual structure and the lowest energy resonance structure is called the resonance stabilization energy or resonance energy. There are two types of resonance: positive resonance effect and negative resonance effect. What is positive resonance effect? In this effect, the transfer of electron is always away from the atom or substituent group attached to the conjugated system. Here is an example of plus R effect. If we take aniline, nitrogen containing lone pair of electron, it will donate this lone pair of electron to the benzene ring and you will get 3 canonical structure. So in this example, nitrogen is donating the lone pair of electron and it is itself becoming positively charged. So it is called called that it is showing positive resonance effect or plus R effect. What is negative resonance effect? In case of nitrobenzene, what is happening over here? The electron from the benzene ring will migrate towards the nitro group, as because it is pulling the electron towards itself. So nitro group itself becoming the negatively charged group. So it is what is happening over here. The transfer of electron occurs towards the atom, towards the nitro group or the substituent and it is called the negative resonance effect. So nitro group is showing minus R effect when it is conjugated with the benzene ring. There are some other group which is showing plus R effect, that is positive resonance effect, and negative resonance effect. Now in the last slide, I have put some question related to the topic. Please answer it. Thank you all for your patient hearing.